Hey guys, today we are starting Laplace transform, and this is kind of a lengthy chapter. There are lots of formulas, so those will come by practice. So as long as you keep practicing, you'll remember the formulas eventually. So let's start. So what is Laplace exactly? So for example, you have a function of the variable t, which is defined at t greater than equal to 0. Then your Laplace, which is denoted by L, Laplace of the function ft is given by integral 0 to infinity e raised to minus st times ft dt. Here s is a parameter. So basically you can say that Laplace of ft will give you a different function of s. So let's look at the Laplace of some functions. So the first is if your ft is 1 or if ft is some constant called a. So let's put this into the formula, this formula. So for now you do not need to remember this formula. In the end you will, but for right now just remember what the Laplace of 1 is, what the Laplace of a constant is. So you do not need to remember this working, but I'll show you how we get this formula. So 0 to infinity e raised to minus st multiplied by 1 dt. So this becomes e raised to minus st divided by minus s, 0 to infinity. So if you take out 1 minus 1 by s as it is a constant and you integrate the rest, you'll get 0 minus 1 when you put in these limits. So your answer becomes 1 by s. So this is your Laplace of 1. Similarly, Laplace of a constant a will be a by s, because you will simply take out a over here instead of just 1. Let's look at the second function. What if your ft is e raised to at? So Laplace of e raised to at is integral 0 to infinity e raised to minus st multiplied by e raised to at dt. So you can write this as, let's take out minus t as common, you get s minus a inside. So let's integrate this, you'll get e raised to minus t s minus a divided by minus of s minus a. Now you need to put in the limits, 0 to infinity. Again, I'm going to take out the constant, 1 minus of s minus a. And inside it will become, when you put 0, you'll get, when you put infinity, you'll get 0. And when you put 0, you'll get 1. So this becomes 1 upon s minus a. So this is L of e raised to at. Similarly, if you have L of e raised to minus at, this will become 1 upon s plus a. You just need to remember these formulas, but if you want, you can try and put this in the equation and check. So mainly you will have constant e functions and sine and cos functions and the exponential functions. So let's look at the third one. It is when ft is sine of at. Remember here guys, a is a constant, so it can be sine 2t, sine 3t, something like this. Alright. So let's find out the Laplace of this. this will become integral 0 to infinity e raised to minus st sine of at dt. So guys, generally here we apply integration by parts, but instead you can just memorize this formula. I'll just write down this formula. So integration of e raised to ax sine bx dx is equal to e raised to ax divided by a square plus b square multiplied by sine bx minus b cos bx plus c. So we will be using this formula. So if you apply this over here, you will get e raised to minus st divided by s square plus a square multiplied by minus s sine of at minus a cos of at. Here guys, we do not need to add the plus c since it is definite integration and it will get cancelled out when we applied the limits. So let's go ahead and put the limits 0 to infinity. So I'm gonna take out 1 divided by s square plus a square. Again you will get 0 here, and when you put 0 over here you'll get 0, and when you put it over here you will get a. Sorry, you'll get minus a. So your answer becomes a divided by s square plus a square. This is your Laplace of sine of at. For the next function, ft is equal to cos at. So Laplace of cos at will be integral 0 to infinity e raised to minus st cos at dt. Again we have a formula for this which comes by applying integration by parts twice. So I'll just write down that formula. Integral of e raised to ax cos bx dx is equal to e raised to ax divided by a square plus b square a cos bx plus b sin bx plus c. So this is what we are using. So when you apply this similarly like we did before, you will get Laplace of cos at is equal to s upon s square plus a square. You guys can check this, but for right now you just need to remember these formulas. Let's try the next one. Here your ft is t raised to n, where n can be any number 1, 2, 3, 4. So Laplace of t raised to n is integral 0 to infinity e raised to minus st multiplied by tn dt. So here what we are gonna do, we're gonna write st as x. So you get s dt as dx. So Laplace of tn becomes integral 0 to infinity e raised to minus x, and your t becomes x by s raised to n dx divided by s, as you can write dt as dx by s. So I've just substituted these. So let's go ahead. So this can be written as e raised to minus x multiplied by x raised to n multiplied by s raised to n plus 1. S raised to n here and s raised to 1 here, so you can add those. So let's take out the constant. 1 divided by s raised to n plus 1, integral 0 to infinity e raised to minus x, x raised to n dx. So if you remember, guys, you might have done this in calculus. This is your gamma function. It is denoted by this. So this becomes L of t raised to n is gamma of n plus 1 divided by s raised to n plus 1, which can be written as n factorial divided by s raised to n plus 1. So again, guys, you do not need the working, just remember the final answer. Now we have 2 more functions to go. We've done sine and cos. Now let's do sin h and cos h. So if you have ft is equal to sin h at. Now sin h of at can be written as e raised to at minus e raised to minus at divided by 2. So Laplace of sin h of at is equal to Laplace of e raised to at minus e raised to minus at divided by 2. Now you can separate these. So we know that L of, let's take out half first. So this becomes half of L e raised to at minus L of e raised to minus at. Now remember, guys, we have already calculated these two. So this is s minus a, 1 upon s minus a and 1 upon s plus a. So let's write this over here. This becomes half of 1 upon s minus a minus 1 upon s plus a. Let's take the LCM. Half of s plus a minus s plus a divided by s minus a into s plus a. So your s and s get cancelled. This becomes half 2a divided by s square minus a square. So we'll cancel this and your final answer becomes L of sin h at is equal to a upon s square minus a square. Now your last function is ft is equal to cos h of at. I'm writing the formula directly. If you want, you guys can check it by doing the integration. This will come out to be s divided by s square minus a square. So remember, guys, all you need to remember right now is the final answer. So you need to remember this, 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 and this. And I know these are a lot of formulas, but this is your basic foundation for starting Laplace. So let's do a couple of examples so you get the hang of it. So I'm going to start with a simple example. So find Laplace of root t minus 1 whole square. So let's open this. This becomes L of t plus 1 minus 2 root t. Now you can put these as different. You can write it as L of t plus L of 1 minus twice of L of root t. So basically you can separate these terms. Now we know the Laplace of t, right? This is Laplace of t raised to 1. So this becomes 1 factorial divided by s raised to 1 plus 1. So this becomes 1 factorial divided by s raised to 1 plus 1. Plus L of 1 you already know as 1 by s. Now what we do not know is Laplace of root t. So let's write this as twice Laplace of t raised to half. Now we do not know half factorial, but we do know gamma function. So if you guys do not know gamma function, you can refer the other videos I will be making in the calculus playlist. So for right now, I'll just tell you the answer. This is 1 upon s square plus 1 upon s minus twice Laplace of, we had, the formula was gamma n plus 1 divided by s raised to n plus 1. Here n is half. So you will get, this becomes gamma of half plus 1 divided by s raised to half plus 1. So 1 upon s square plus 1 upon s minus twice gamma of 3 by 2 divided by 3 by 2. Sorry, s raised to 3 by 2. Now you can write gamma of 3 by 2 as half gamma half. Again guys, this is the gamma function. You need to know about it a little bit, just the basics. So you can watch any other YouTube videos, or you can watch my own YouTube video that I will be making in the next couple of days. So let's solve this. Now what you need to remember is gamma of half is root pi. Remember this. So 1 upon s square plus 1 upon s. Sorry, this is s guys, not s square. This 2 and 2 gets cancelled. So you get minus root pi divided by s raised to 3 by 2. So this is your final answer. Now let's try a different question. So find Laplace of 4t cube plus cos 3t plus e raised to 5t. Now to solve this, you only need to remember all the formulas that we did. So first of all, you can take out the constants and you can separate these terms. So this becomes 4 times Laplace of t cube plus Laplace of cos 3t plus Laplace of e raised to 5t. So this becomes 4 times 3 factorial divided by s raised to 3 plus 1 plus Laplace of 3 divided by s square plus 3 square plus 1 divided by s minus 5. So this becomes 4 times 6 is 24 divided by s raised to 4 plus plus 3 divided by, you don't need L over here, remove that, s square plus 9 plus 1 upon s minus 5. This is the answer. So guys, there are a lot of more examples in my notes. You can go through them. So next we will be doing Laplace of broken functions. So for now, just try to remember the formulas of the 7 functions that we have written, and we will continue in the next video. Thank you.